Okay, it's 8 o'clock. It's Wednesday. We have parent-teacher conferences. We have a shortened schedule today. Can someone pull it up on their computer? I guess I was wrong. It's now 8 o'clock. Someone pull up the new schedule for today on the computer. We only have 20 minutes. I know that. So we'll be done. 27 minutes. Thank you. So we'll be done at 8:27. So let's get moving. We don't have a lot of time, so I'm going to go ahead and start. Assuming my... All right. Yesterday, I believe we started talking about graphing, correct? And I gave you like three general types of graphs. I said a pie graph. And what do we use pie graphs for? Percentages. That's kind of easy. And when we have a graph where we have, when we want to do a bar graph, when do we want to do a bar graph?
Categories.
Yeah, that's right. Categories. Excellent. Yeah. No, but you can go to the restroom. Take the pass. I'm sorry. I had 2 boxes of tissues, but they're all gone. Kids use them. I don't know how they, honestly, I used to buy snacks and I'm like, where did they go? I don't have
You buy snacks for students?
Yeah, because we're not allowed to anymore. They don't allow, I used to have a whole little kitchenette there, coffee, tea, honey, sugar. It was nice. I think the kids liked it. But unfortunately, and I kept the room clean. You see the mop, I had mops and brooms. I made sure the room was clean so nobody complained. But unfortunately, kids abused it and left food in the halls, in the locker. And the district said, no more. We can't do this. So they said, no food in the classrooms.
We're more responsible than them.
Yeah, that may be true, but unfortunately, rules have to be made for everyone. They can't just be made for one group and not the other.
But rules can be changed.
Yeah, maybe in the future we'll have it again. I gave away my microwave. I had a microwave there, and I gave that away. And I have my coffee pot in the back because I don't have sugar. I figure I'm allowed to make some coffee, black coffee. So scatter plot. How do we grab that? Right, very good. We're going to make a best fit line is correct. Very good. But that's how. But when do we use a scatter plot? When we have data that is that needs, I shouldn't say is. Needs to be analyzed as to the sorry about that. My brain's in different places today. As to how one affects the other. So you're comparing 2 sets of data, but you're not comparing sizes, you're not comparing categories, you're comparing a series of numbers, like I said in XY, you have numbers and you want to try to find a pattern. When the scatter plot is really good for finding patterns. So obviously, everybody agrees does everybody agree that this is a line? And we call it a best fit line? It's a guess, right, and all that. It's a guess on what? On the relationship between X and Y. What is that relationship? In this case, it's what? If I were to ask you what the relationship between X and Y is, what would it be? As x increases, y increases. So as x increases, y increases. So it's a positive relationship, correct? On the other hand, if you saw a relationship that was this, and the best fit line was something like this, what would you say? It's a decreasing best fit line or a negative relationship. Now, so these are linear. You agree? So we call it linear regression, best fit line, and on the computer Excel, which you'll have to do in one of the labs that you're going to have to do in this class. On Excel, you're going to do something called linear regression. It's a fancy word for a mathematical way of calculating this best fit line. Linear regression increases accuracy by increasing precision. It's not so much a guess as a mathematical formula that allows you to calculate what is literally the line of best fit. So that's linear. It's going to look for a line. It's going to draw a line. Now, what if I had data that looked like this? If my data looked like this and I told it to do linear regression, it would still draw a line. It wouldn't be any use to us because that's not a line. There's no way you can, I could draw a line. Let me draw a line for you. Let me copy this. I could draw a line through it. Watch. I can draw a line anywhere I want. I'll draw a line like this. Okay. But that doesn't.
Please pardon this interruption. Staff members, if you would like to get a flu/COVID shot, you can do that in the auditorium up until 8:30 today. Thank you.
These are facts. These are data points. The red line is a guess as to the pattern that the data shows. Does it look to you like this line represents the pattern in this data? Yes, hello everyone. Thank you for coming. I know you're a little late, but hello. Has everybody said hello? Okay, hi. All right, now let's go. So line goes through the data, but does it represent this data? Look at it. No, it doesn't. And the way I would draw, what I would think would be the better fit line would be something like this. Do you agree? And I hate that I can't draw it without wiggling, but it's hard for me in this angle. Let me move the... So it looks something like that. And that would be called exponential. So this kind of is, you wouldn't have a linear, this is not a linear regression. Linear regression makes a what? A straight line. So we can't use linear regression, we would use exponential regression. Exponent. Exponential. This is exponential regression. Right? So it draws a best fit line that matches the pattern. So the difference is I know that as x increases, y decreases here, x increases, y increases here. I know that as x increases, y decreases at first really quickly, then it slows down and stops, and then it increases really quickly. That's called exponential regression. I can tell that. If I had another graph that looked like this, that's not exponential growth, right? They don't match. They kind of have a little bit of that exponential growth at first, right? Yes? But it doesn't really decrease, does it? It goes up pretty quickly, maybe as a line, maybe it goes up as a line, maybe it goes up really quickly as maybe it's exponential at first. But it turns out that the best fit line is something like this is called, it looks like this, it starts like so, and then goes up, and then plateaus. That is called logarithmic, like the log button on your calculators. So these patterns are important because you're going to see when we look at predator-prey models, when we look at the relationship between predators and prey, when we look at what we call something called carrying capacity, what we see is this logarithmic pattern. So our best fit line would look like that. What you'll see is you'll see drawings of graphs that look like, something like that. You might say that this part here is exponential, but as the graph as a whole is logarithmic. Are we all good with that? Does that seem like something that's pretty straightforward? You just got to remember it. Do you have to remember exponential regression? No, I'm not going to ask you that. But I'd like you to know, to see the patterns. Do you see the patterns? Do you see that they're different? Do you see how one decreases quickly, increases? If you learn these, that's really great for you. So we're going to call these tiers. All right, so there'll be extra credit questions on the test. Not tomorrow's test. Not tomorrow's test. Tomorrow's test. Tomorrow you have a test. Tomorrow's test is just on chapter 1. It's not on graphing.
It's just what we read.
Yeah, I just want to point one thing out is that, let me just zoom in. On which one? This one here? Yeah. Huh? Yeah, of course. So I would say that when you're talking about these patterns, just recognizing the patterns and understanding that when you have data, not everything is in a line. That there's different shapes to the data, and the shapes tell you something about what that relationship is. X is to Y. So X could be how many wolves you have, and Y could be how many rabbits. X could be how much water you have, and Y could be the number of people. So as you have more water, you have more people. It could be anything. It could be money. It could be money at the stock market. Smartwatches shouldn't be looked at. Texting, this has to be turned in. Give me the watch. I have to turn in. Why would you do that? Sorry. Have it out. You know you're not supposed to have it. Why would you have it out? Then I gotta take it and make my life. It's okay. I'm not saying you are, but wait, don't just give it to me. You have to put your name on it. I have to turn it into the office. I'm just holding it. I got to turn that. They want me to turn it into the office. They said smartwatches and phones have to be in the case. Otherwise, they said iPads are okay. That's what they said. If I'm wrong, they'll correct it. Hold on, I have one here, but I don't like using them. But for this, but here. Put your name. You want to just go to the office and turn it in now? And I'll check with, put your name on it so you can give it to them. Just tell them, I'll tell them after class, just tell them that I told you to go turn it in because you were using it, okay? I'm sure you can be honest with them. It's okay, it's not a big deal. They'll just put it away. Oh, well, I'll take care of it then. All right, so just know the patterns, guys. Tomorrow, scientific method, all right? Scientific method, don't forget.
When you worked in here, I can watch that for
Yeah, I think so. Also, I'll be here after school.
class.
I'll be here after. I am here after school. I'll be grading and getting stuff together for your parents. Open houses today, as you all know. What classes do you have next? What class do you have next? Sit here until I get back. Watch my stuff. You here. I gotta go to the office real quick, turn this in. I'm just trying to take attendance in my head. All right, we're good. Let me get this water, this coffee. Is it time to go or not?
We got about like a couple of seconds. It's time to go.
All right, let's go.
She can see hey, I'll you gotta stand
I got Gatorade on my. Class ended, guys. That's so sad.
No, for real, we would have still been here for another 40 minutes.
20 minutes actually, because
You quit correcting me. When I say y'all, we in class at 8:47. Wait, what? Did you want a cookie for no Shut up, Ryan. Shut up.
Good
actually I'm not done.
Come on, Ryan. Come on. There we go. We finna get the thing, right?
Over here talking about something. Huh? Where'd he go?
He at the office.
About to get that sun.
Every day.
What class do you have next? Oh, you're watching his class?
No, this finger's gonna get
You're gonna write to a class.
You better.
And if you don't, you're gonna eat his ass too.
Thank you. Let me write your pets. I just don't like to have anyone not have order, you know. When there's no order, there's no responsibility. And thanks this morning for helping me put down the chairs. Appreciate it. What is today's date? That's right. That's crazy. 21 years.
21 years.
There you go. Thank you. Can you go to the restroom? Yes, absolutely. All right, ladies and gentlemen, let's start talking. That back area, I had to sweep up. I'm going to talk to every period. I'm not blaming any one group, but it's a mess. When I sweep up this area here, I see gum right behind Woo, and I got to scrape that gum up. I don't appreciate it. I don't know who did it. I don't know if it's Woo. Is it someone else? I don't know. I know everybody says not me. See, that's the problem. When I was a kid, as I told you before, I was always fat, and my father he'd come home, he'd be having a hard day's work, and he'd like have a sandwich hidden in behind his sodas. And Saturday morning and Saturday afternoon, he'd get up, he'd want to cook up his sandwich, and he'd go look for it, it's gone. And it's only me and my brothers in the house. My mom was off doing working or whatever. My old man would line us up and say, "Which one of you did it?" All three of us looked at him and said, "Not me." He's like, there's only four of us in the house.
Was it you?
Yeah, it was me. But I looked at him and said, "No, it wasn't me, Dad. Not me." And that old man would get so mad. I looked at him straight in the eye and said, "Not me. Not me." To this day, I'm like, "Dad, what did you want to do?" He said, "I wanted to kill you, son. I wanted to kill you right there." I said, "Dad, why did you hit me?" He said, "I didn't have any evidence." If I had evidence, you would have got hit. Because for lying to me, not because you ate a sandwich. I said, "Okay. Fair enough." Ladies, you're talking. And my problem is that back there, I get papers, pencils. What did I sweep up yesterday? Bunches of dust, hair. I mean, dust, I'm talking about wads of like, I don't know what it is, schmegma. Which you can't blame anyone for. It's just random, probably from the filters, the air filters. But paper, water bottles. There were like 5 water bottles. Now, I'm not blaming you all. I'm not blaming Woo. I'm just saying that's the area. And every period, I'll be checking after you leave. And also, I want to break up some of these groups all day. So there's only 3 of you at this table, so I can hold you 3 accountable. It's going to be hard for me to hold 5 people accountable. So I'm going to ask 2 of you, 2 of those 5, to voluntarily move, or I will move you. Oh, the teenage angst. Ladies, come on, just 2 of you move. Okay, no reason to get upset. Okay, no reason to get loud. So while they make that decision, do y'all hear me? I said there's 2, right? So, oh, there's 2 moving. I only see 1 packing. I'm sorry. And then the rest of you, why don't you turn around and sit on that side of the table and face this way. Ladies? Oh, okay, my bad. Did y'all pick up on that attitude, or is it just me? Am I misreading that? Look, do y'all see it? Like, please witness how slowly everyone moves. This is an old trick, kids. Kids, I think, are born with this technique. My nephews and nieces would do it. I'd say, pick it up. They do this. They get up and go. By the time they got about here, they felt, pow! Okay, Dad, Uncle, okay, Uncle. Okay, yeah. I said, move. I think y'all, is it on purpose? Let me ask you, when you move slow, is it on purpose? Kids in general? Yeah, it's on purpose. Like you could move quickly if you wanted to. You just want to make sure the adult knows that you're not gonna jump when they say jump. You'll get it done, but you'll do it on your time. All right, so just let's make sure we keep that area. However it was when you came in, please leave it like that when you leave, and I think we'll be okay. All right, graphing. When we have graphing, we look at graphs. We look at these two. What kinds of data would you graph using this one? Percentages. What do we call this? And what would you graph using this one? Categories. And this is called a bar graph. Correct. Excellent. So you should know that by now, right? Straightforward, easy. And you probably had it before. Scatter plots, as we said before, therefore looking at data, usually 2 sets of data. Sometimes you have 4 or 5 sets you're putting on one graph, but you're looking at a pattern. You're looking for patterns. If you're looking for patterns and how it changes, then you're going to want to do a scatter plot. And we all know best fit line, right? That's the red line, that guess between the data points. We're all good with that? This is not going to be on the test tomorrow. Just want to make sure you all know that. The test is tomorrow. It's not going to be on the test tomorrow. Tomorrow's on scientific method. We went through that. But we do have to understand that we can do the same thing, the same kind of best fit line, or they'll sometimes on Excel they'll call it a trend line. It'll be called a trend line. They'll use something called linear regression to make a line. Does that make sense? That makes sense, right? Linear regression to make the line. They're going to use a mathematical formula to create that. Why don't we put those computers away and actually pay attention to what's on the screen and write things down if they need to be written down? Wait, why are you talking back to me? I'm sorry, I misunderstand. Oh, okay. Well, the attitude, you can drop that. Is that okay? If you don't like the attitude, if you want to give me attitude, I don't want to turn this into a negative interaction. But it can go down that road. Why do you need the computer to write something down? You can't see? Then move up here. Move up here. There's a seat here if you can't see. That goes for anyone in the room. Close your computer. If you can't see, there's a chair here, there's a space here. Please don't use that as an excuse. So, in any case, when we're looking at a best fit line, we have data and we draw the line that fits through the data. And that tells us a pattern. Now, obviously, if we're using linear regression, the computer is going to draw a line, correct? But if we see data, I'm going to redraw it because I didn't record this. Oh, no, did I? So again, age is the independent variable. We should be able to identify that. Then height would be here. In feet. Age in years. Notice I put units. These are called units. Everybody understand that? All right, so this is a unit. Now, what is your problem? And I can even do a title, age versus height for Johnny. Okay? So there's my title, there's my age, there's my height. What is your issue now? How are you going to graph this? Are you going to use a bar graph? No. Is my objective is to predict how tall am I going to get? Assuming I keep everything the same, how tall am I going to get? Say that again.
Scatter plot.
A scatter plot. So I'm going to do a scatter plot. Okay, so now what? So I got that settled. It's scatter plot. We're good. It's not going to be a percentage. It's not a percentage, so it won't be a pie graph. All right. So now how do I do the axes? That's going to be a problem, isn't it? Like how do I divide the lines? I got a bunch of lines. If I have graph paper, I got lines, great. But what is it I'm going to do to get the divisions? Do I just do this? Can I just do, oh, you know what? I'll just do 5, 6, 7. This is what kids do. What I'm doing right now is what people do. So just be careful. 8. Oh, I'm sorry. That's it. Yeah, my bad. So let me copy this. And let me show you the wrong way. And hopefully then the better way of doing it. Okay? So what kids will do is they'll say, okay, well, I got a height of 3 foot. So I'm going to go ahead and put 3. See, every time I switch now with this app. Wow. So so what kids will do is they'll say, okay, well, the height's 3, then 3.5, then 4, then 4.5, then 5, then 5.2. Is that how you do it? That is not how you do it. You can't just put randomly. Why are you putting things away? Why are we not looking at the board, writing down what I'm talking about, and you're putting things away early? What's your name, dear? What's your name? Help me, remind me. Huh? Lene. Do me a favor, Lene. Stay after class, please. Thank you. And rolling your eyes and throwing your head back did not help. Please don't put your things away. It's not funny. It's time to go when I dismiss you. You'll notice that I'm wasting time right now. I probably wasted 30 seconds. Do you hear anyone in that hallway? No. It's not time to go. It's not time to go. And we've wasted 2 minutes me having this conversation with you. So everyone needs to stop. I'm monitoring the time. If you have a concern about time, you can raise your hand. But your attitude is really poor. And it's starting to impact the classroom structure. It's starting to impact instruction. And I can't allow that to happen, please. I wanted to have that conversation after class. So 3 to 5.2. Now we have, what we should do is have a scale where the maximum is probably, because I want to know what's going to happen in the future in the end, the maximum should be higher than 5.2. I'm going to assume I'm going to grow taller, right? So I'm probably going to want to put what? What's my maximum height probably going to be? 6, it's probably 6 foot, 6.2. It might be higher, but I could start with 6 foot and maybe have to regraph it, but I'll put 6 foot. All right, so I'll put 6 foot, 6.0 feet. And so I'm going to start with, I could start with 0, but 0 isn't very useful. I can start with 3. And I got to go from 3 to 6. And I have, let's say I have, if I count my lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What I have here is 15. How many lines you have depends on your graph paper. Does that make sense? But I have 15 here. So here I'm going from 3. Why did I start with 3? Because I'm not going to start with 0. I don't need to start with 0. I'm not concerned about 0 height. 3 feet. I start with 3 feet, and I'm going to end up. So my final is 6 foot. So 6 minus 3, right? Final minus initial. That equals 3. Then I divide it by 15. So 3 divided by 15 is what? Is 0.2. So every one of these, 3 divided by 15 is 0.2, correct?
Oh, yeah. I did it.
Yeah, you did it the other way, which is fine. 3 divided by 15 is 0.2. So this is 3. What's this one here? 3.2. Then 3.4. Then 3.8. Then what? 4. Is it time to go? Well, I'll continue this, but do you see how this is something very few people actually think about doing?